Good morning and welcome back to our regular distance learning classes. It's me, your science teacher. Today we'll learn about the chapter heat from this class 8. In this chapter we'll learn more about the definition and basic molecular definition of heat and temperature. Similarly, the working mechanism of the different instrument that is used to measure the heat and temperature and different units of temperature, that is in which the temperatures are measured, like their scales and their relations. Okay, now to the slide. In slide, this is the first slide. After the chapter, we will learn basic knowledge of heat and temperature, structure and working mechanism of simple and clinical thermometer, and the different units of temperature and their relation. So, first of all, without delaying, what is it? We are all familiar about the definition of energy. First of all, we all are familiar to the definition of energy, that is, energy means capacity of doing work. If something is execute, or if something is performed, then it is called energy. So, it is also a form of energy. We may say that it is also a form of energy, or it is a form of energy which gives the sensation of warmth. So, the heat is the form of energy that flows from warmer bodies to the colder bodies. That is, due to differences in the temperature, we may find or we may feel that something is very cold, something is very hot. So, it is viewed as a form of energy that is transferred from one body to another body due to the differences in temperature. If the temperature is same of the two bodies, again, if the temperature is same of two bodies, then no heat will flows and we do not feel it. So, for the sensation or for the different or flow of heat, there must be the differences in the temperature. And let define the heat on the molecular basis. First of all, look at the board. Every substance is made from the molecule. Every substance is made from the molecule, and in every substances the molecules are arranged accordingly. Means they are arranged in such a form that they form a fixed shape, or either they form a fixed volume. So, these are the substances and these are the molecules. These are the molecules, and in the substances or in an object, all molecules are in motion. That means it possesses the kinetic energy. All the molecules are in motion means they possess the kinetic energy, and every molecule are attracted with each other like this. Every molecules are attracted to each other by a force known as intermolecular force of attraction. Intermolecular force of attraction. This force of attraction is strong in solid. This force of attraction is stronger in solid, less in liquid, and weak in gases. So, the molecules of the gases are free apart. So, gases do not have fixed volume or fixed shape. So, these molecules are in motions and these molecules possess the kinetic energy. So, on molecular basis, heat is defined as the total sum of kinetic energy possessed by the molecules present in that object. Like, the total kinetic energy means this is an example of any types of substances, and this substance is made from these types of, or possesses these types of molecules. These molecules are in the state of motion, that means they possess the kinetic energy, and heat on the basis of molecular level can be defined as the total sum of kinetic energy possessed by the molecules, means larger the number of molecules, more the number of molecules, more will be the heat energy in that object. So, it is directly proportional to the number of molecules present in that object or the kinetic energy possessed by that object. Heat present in an object is directly proportional to the number of molecules or kinetic energy of the molecules, means more the number of molecules, more will be the heat energy. For example, or for instance, we see that this is 1 liter of lukewarm water and this is 3 liter of lukewarm water of same temperature. This is of 30 degrees Celsius and this is also of 30 degrees Celsius. Now, which one will have more heat energy? Obviously, the 3 liter of water contain more number of molecules, so the heat energy contained in the 3 liter of molecule will be obviously more than the heat energy contained or heat energy in the 1 liter of the molecule. So, 1 liter of the water. So, in the slide we have that on molecular basis, heat is defined as the energy produced. Heat is defined as the energy produced by the vibration of the molecule. The vibration of the molecule means the kinetic energy. The kinetic energy that is produced by the virtue of motion. Kinetic energy that is produced by the virtue of motion. So, every object is made of the molecules and the molecules consist of kinetic energy as they are in the state of motion, and the sum of total kinetic energy present in the object is termed as heat energy. So, on molecular basis, heat is defined as the energy produced by the vibration of the molecules, and kinetic energy is produced by the vibration of the molecules. The total sum or the sum of total kinetic energy of all molecules of a given body is called heat. Its SI unit is joule. SI unit is joule, and the common unit of the heat in which heat is measured, that is common unit. We generally use the common unit of, although the unit of SI unit of heat is joule, but commonly the unit of heat is calorie. The unit of heat is calorie. So, 1 calorie heat. Now, 1 calorie heat is defined as the amount of heat required. The amount of heat required to raise the temperature of 1 gram of pure water by 1 degree Celsius. Look, there is 1 gram, so it is CGS unit. So, it is CGS unit, and the relation between the calorie and joule is 1 calorie of the heat is always equal to the 4.2 joule of heat energy. Means 1 calorie heat energy or 1 calorie is equal to 4.2 joule. Remember this point, 1 calorie is equal to 4.2 joule, and heat is measured, or heat of the body or heat energy is measured by a device called calorimeter. Device called calorimeter. In the figure you can see that this is the calorimeter, and the substances or the heat energy of which substances need to be measured is kept in the vessels. There you can see it is labeled. So, this instrument is calorimeter. It measured the heat energy of the given substances. Now, transfer of heat energy from hotter body to colder body. See the slide, and what will be the conclusion? There are the two different temperature of water. There are two glasses of water with different temperature, and if these water get mixed with each other, again water with 40 degrees Celsius and water with 60 degrees Celsius are mixed with each other, then what will be the final temperature of that water? Whether it increase from 60 degrees Celsius or decrease from 60 degrees Celsius, or increase from 40 degrees Celsius or decrease from 40 degrees Celsius, and what will be the conclusion? So, let us look at the board. We will go through the conclusion here. Okay. There are the 3 glasses of water. In 3 glasses of water, one is of 40 degrees Celsius, another of 60 degrees Celsius. If these two glasses of water get mixed with each other, what will be the temperature of mixtures? Here in this class, no need to calculate the temperature of mixer, but we just want to show you that the temperature or the heat energy, from where the heat energy are flows or heat energy flows, means if these two objects of different temperature are kept in thermal contact, remind this point, if these two different temperatures or the bodies of different temperatures are kept in thermal contact, then heat energy always flows from hotter object to cooler, that is from high temperature to lower temperature. That means the temperature of 40 degree will increase, and the temperature of 60 degree will decrease. But up to when? Till the temperature of both become same. That means the temperature of 40 degree must increase to a certain point, the temperature of 60 degree must decrease to the certain point when they are kept in thermal contact, but up to when? Till the temperature of both become same. So in the slide we can see that heat energy transfer. In the slide, that is, we can see that heat energy transfer 40 degrees Celsius in glass A, 60 degrees Celsius in glass B. The mixer temperature will be what? The mixer temperature will be that the temperature will rise from 40 degrees Celsius and decrease from 60 degrees Celsius till the temperature of both become same, and the conclusion will be that heat energy always flows from higher temperature to lower temperature, Now this is time of winter season. We can demo this experiment in our home too. While taking or drinking the sip of tea, it become more colder in winter season during a short time of period. The tea become more cold during the winter season in short period of time, because the temperature of surrounding is too low, and heat energy from the cup of tea, will flow from that cup of tea to the surrounding. That means the temperature of cup of tea tends to decrease and the temperature of surrounding tends to increase till the temperature of both becomes same. That is the conclusion. So the gist point or the conclusion point is heat energy always flows from hotter body to colder body. Now next term is temperature. It is the effect of heating. Heat energy. The molecules of the object are in the state of continuous motion. If their average sum of kinetic energy is taken, at that time the energy poses by that object is termed as temperature. So it is known as effect of heat energy. Heat energy is the cause, but temperature is the effect of it. So it is, in simple term, it is defined as the degree of hotness or coldness of a body. Temperature in general term is defined as the degree of hotness or coldness of a body, and temperature is measured by an instrument called thermometer. There are the various types of thermometer used for different purpose, like for measuring the different boiling points and the melting points. We use the laboratory thermometers, which have very much large range. For measuring the temperature of a body, we use clinical thermometer, which has short range. And for measuring the different types of other things, like mountaineers use the thermometer having the alcohol as the liquid, and similarly for measuring the high temperature, the thermometer with mercury as the liquid is used. So thermometer is a device which is used to measure the temperature, of a body. Thermometers are calibrated in various temperature scales. Thermometers are calibrated in various temperature scales that historically have been used various reference point and the thermometric substance for the definition. The most common scales are the Celsius, which is most commonly used are Celsius. It is denoted, you can see in the slide, it is denoted by degree Celsius. Fahrenheit scale, it is denoted by degree Fahrenheit, and Kelvin scale denoted by Kelvin. And the most predominantly used by the scientist or for the scientific purpose is Kelvin. For the scientific purpose, Kelvin scale of temperature is mostly used rather than degree Celsius and degree Fahrenheit. Generally, the temperature of body is measured in degree Fahrenheit. We are used to that term degree Fahrenheit, and others boiling point and the melting points of the substances is measured in degree Celsius, which are very used to the common people too. And on molecular basis, as already defined as molecular basis, the temperature is defined as an indicator of the average kinetic energy. See, that definition is the average kinetic energy of the molecules of that body. Means body contains, or an object contains different number of molecules, and different number of molecules or different number of molecules are in the state of different motions, not in the similar motions. And the average sum of that molecules means average sum of the kinetic energy of that molecule is termed as temperature. So in the beginning I told you that temperature is the effect of heat energy, not the cause. Heat is the cause, but temperature is the effect. Sure, in last point, higher the average kinetic energy, as already mentioned, higher the average kinetic energy, higher is the temperature of the body. Higher is the temperature of the body. Now see, that is the difference. Only 2 points I have given here, that is total sum of kinetic energy of all vibrating molecules of a matter is heat energy, temperature is the degree of hotness or coldness. You can make the differences like that. The total average sum of kinetic energy, average sum of total kinetic energy of the vibrating molecule is defined as temperature too, and it is measured by using calorimeter. That is the instrument which is used for measurement of heat energy. Similarly, thermometer is measured, or temperature is measured by thermometer. Temperature is measured by thermometer. You can add the another point too. Temperature can be measured in the different scales like degree Celsius, degree Fahrenheit, degree Celsius, degree Fahrenheit, and Kelvin. Similarly, heat energy is measured in joule and calorie. Commonly used is calorie, and heat is the cause, temperature is the effect. Now to the next slide, that is the instrument called thermometer. As already described, thermometer is a device which is used for measuring the temperature of body, and it's work on the principle that when a body is heated, it expands and contracts on cooling. That means being the thermometer, or for the thermometer, different types of substances are used as thermometric substances, like gas and liquid are used as the thermometric substances. The thermometric substances must possess this property, like they must expand when heated and contracts on cooling. And generally gas and liquid, not solid, gas and liquid are used as thermometric. Nowadays digital thermometer has been in used, which does not needs any types of that liquid. It works on thermoresistor. Only we describe that gas and liquid which are used in our daily life, which are used in used since ancient time for our different purpose. Gas and liquid are used as the thermometric liquid. So, what is liquid thermometer? Means those thermometer in which liquid are most commonly used. Those thermometer in which liquid are most commonly used as the thermometric liquid for the purpose of measuring the body temperature, room temperature, temperature of the different bodies, and the maximum and minimum temperature of a day or different places. That is the liquid thermometer. Let's have slide. In slide you can see that there are different types of thermometer. There are different types of thermometer on the basis of liquid too, that is thermometric liquid too, and this type of thermometer is based on the principle of thermal expansion of liquid. Thermal expansion of liquid, that means liquid must possess those characteristics, like they must expand on heating and contract on cooling. And the most commonly used liquid in the liquid thermometer are alcohol and mercury, as I highlighted there, alcohol and mercury. So, alcohol and mercury are known as thermometric liquid. What due to which? Because they shows the property like expand on heating and contract on cooling. Then mercury, why it is used? Mercury is used because of the following property, as it is a very good conductor of heat. Means if it is supplied, to the mercury, it shows the uniform expansion and contraction. It shows the uniform expansion and contraction. It is easily visible due to its silvery shine, easy to look or easy to read. Remains in liquid state over a wide range of temperature. It remains in the liquid state over a wide range of temperature. That is, the freezing point is minus 39 degrees Celsius. It can measure the temperature up to minus 39 degrees Celsius and boils at 357 degrees Celsius. Means it can measure the temperature up to 357 degrees Celsius. So, it is generally used as a high temperature thermometer. It is not used for measuring the low temperature thermometer or low temperature, because its boiling point, its freezing point is minus 39 degrees Celsius, and it is not suitable for the mountaineers too. There in mountains, this temperature may not be limit. This temperature may not be limit. That is, in mountains the temperature may reach up to the minus 50 degrees Celsius. At the time the liquid itself get freezed. The liquid used in the thermometer itself get freeze. So, it does not give the reading. So, it is not used as the low temperature thermometer, but it is used as a high temperature thermometer. Generally 357 degrees Celsius means high temperature. It can measure up to the temperature of 357 degrees Celsius. And one major property is low specific heat capacity. Low specific heat capacity means exchange of heat energy is very fast in mercury. Exchange of heat energy is very fast in mercury. That means it easily expands and contracts on supplying the low amount of heat. There will be the exchange, or there will be the change of temperature in mercury with very low quantity of heat energy or very low quantity of temperature. It can change its uniform expand, it can expands and contracts with supplying or with the detection of very low temperature, specific heat capacity. And in general term, the specific heat capacity is defined as the amount of heat energy. Specific heat is defined as the amount of heat energy required to raise the temperature of 1 kg pure substances through 1 degree Celsius, and the heat energy required to change the temperature for the mercury is very low. So, it is best to use the thermometric liquid. Mercury is best to use as the thermometric liquid, and another major property is it does not weight the wall of capillary tube. It does not weight on the wall of capillary tube. That means it does not show the variable readings by sticking on the wall of capillary tube. It just flows and flows back, flows up and flows back in the capillary tube. And the one is last, there is a question, you can see that mercury thermometer cannot be used to measure the temperature in very cold region. Justify because the freezing point of mercury is minus 39 degrees Celsius. The freezing point of the mercury is minus 39 degrees Celsius, and in the cold region the temperature may exceed the minus 39 degrees Celsius, means may be below the minus 39 degrees Celsius, and it itself get freezed over there. So, in very cold region mercury thermometer cannot be used to measure the temperature. Again I am going to repeat the answer. The freezing point of the mercury is minus 39 degrees Celsius, and in the very cold region the temperature may reach below the minus 39 degrees Celsius, may reach below the minus 39 degrees Celsius, and the mercury itself get freezed over there. So, it does not use to measure the temperature at that region. Now, next one is alcohol. Why alcohol is used as liquid in liquid thermometer? Because of the following property, that is, it is more sensitive than the mercury for the detection of temperature. That is, it also shows the uniform expansion and contraction. Freezing point, let us see the freezing point, that is freezing point is minus 117 degrees Celsius, and the boiling point is 78 degrees Celsius. So, it is specially designed or specially used as the low temperature thermometer, especially designed or especially used as the low temperature thermometer, that is, it is especially used by mountaineers, especially used by the mountaineers. Like in mountains, we may not reach to the temperature to the minus 170 degrees Celsius. So, at that temperature too, alcohol can measure the temperature of high hills, high mountains. And what are the disadvantages? Colorless, so it is hard to detect. So, before reading or before using, we must color the alcohol. Before using the alcohol in the alcohol thermometer, we must color. And the one is white on the wall of capillary and cannot measure the temperature of highs, or cannot measure the high temperature as it has low boiling point. There is one question. In that question you can see that why is water not as thermometric liquid? Why is water not used as thermometric liquid? One. Another question may like why alcohol thermometer is not used for the measurement of boiling point of water. This will be the homework for tomorrow. We will discuss more about the clinical thermometer and laboratory thermometer and different scales of temperature in tomorrow classes. First of all, just do this task. Why is water not used as thermometric liquid? Another one is why is alcohol thermometer not used for the measurement of boiling water? Till then, have a nice time. Bye. Thank you.